Hello everyone, I'm Siriji from Shri Venkateshwara College of Engineering, studying in 8th SEM, Department of Computer Science and Engineering. I'm here to discuss about the topic Internet Small Computer System Interface. Internet Small Computer System Interface is a transport layer protocol that describes how small computer system interface packets should be transported over a TCP/IP network. iSCSI, which stands for Internet Small Computer System Interface, works on top of the Transport Control Protocol and allows the SCSI commands to be sent end-to-end over local area network, wide area network, or the internet. IBM developed iSCSI as a proof of concept in 1998 and presented the first draft of the iSCSI standard to the Internet Engineering Task Force in 2000. The protocol was ratified in 2003. iSCSI makes it possible to set up a shared storage network where multiple servers and clients can access central storage resource as if the storage was a locally connected device. iSCSI implementation. iSCSI is an IP-based protocol that establishes and manages connection between host and storage over IP as shown in the figure. iSCSI encapsulates SCSI commands and data into an IP packet and transports them using TCP/IP. iSCSI is widely adopted for connecting servers to storage because it is relatively inexpensive and easy to implement, especially in environment in which an FC storage area network does not. iSCSI components. Components of iSCSI include iSCSI initiator, target, and an IP-based network. iSCSI initiator. An iSCSI initiator is a piece of software or hardware that is installed in a server to send data to and from an iSCSI-based storage array or iSCSI target. When a software initiator is used, standard Ethernet components such as network interface card can be used to create the storage network. But using a software initiator along with NICs leaves virtually all of the processing burden on the server's CPU, which will likely have an impact on the server's performance handling other tasks. An iSCSI host bus adapter is similar to the fiber channel HBA. It offloads much of the processing from the host system's processor, improving performance of the server and the storage network. The improvement performance, however, comes at a cost, as iSCSI HBAs typically cost 3 or 4 times as much as standard Ethernet NIC. A similar but somewhat less expensive alternative is an iSCSI offload engine or ISOE, which, as its name suggests, offloads some of the process from the host. iSCSI target. In iSCSI configuration, the storage system is the target. The target is essentially a server that hosts the storage resource and allows access to the storage via one or more NICs, HBAs, or ISOEs. iSCSI host connectivity. The three iSCSI host connectivity options are a standard NIC with software iSCSI initiator, a TCP offload engine NIC with software iSCSI initiator, and an iSCSI HBA. The function of the iSCSI initiator is to route the SCSI commands over an IP network. A standard NIC with a software iSCSI initiator is the simplest and least expensive connectivity option. It is easy to implement because most servers come with at least one and in many cases two embedded NICs. It requires only a software initiator for iSCSI functionality because NICs provide standard IP function encapsulation of SCSI into IP packets and decapsulation are carried out by the host CPU. This places additional overhead on the host CPU. If a standard NIC is used in heavy input-output load situation, the host CPU might become a bottleneck. TOE NIC helps reduce this burden. A TOE NIC offloads TCP management function from the host and leaves only the iSCSI functionality to the host processor. The host passes the iSCSI information to the TOE card, and the TOE card sends the information to the destination using TCP IP. Although this solution improves performance, the iSCSI functionality is still handled by a software initiator that requires host CPU cycles. An iSCSI HBA is capable of providing performance benefits because it offloads the entire iSCSI and TCP IP processing from the host processor. iSCSI topologies. Two topologies of iSCSI implementation are native and bridged. The native topology does not have FC components. The initiator may be either directly attached to targets or connected through the IP network. Bridge topology enables the coexistence of FC with IP by providing iSCSI to FC bridging functionality. For example, the initiators can exist in an IP environment while the storage remains in an FC environment. Native iSCSI connectivity. FC components are not required for iSCSI connectivity if an iSCSI enabled array is deployed. In the figure, the array has one or more iSCSI port configured with an IP address and is connected to a standard Ethernet switch. After an initiator is logged onto the network, it can access the available LUNs on the storage array. A single array port can service multiple host or initiator as long as the array port can handle the amount of storage traffic that the hosts generate. Bridged iSCSI connectivity. A bridged iSCSI implementation includes FC components in its configuration. The figure in bridged iSCSI connectivity to an FC storage array. In this case, the array does not have any iSCSI port. Therefore, an external device called a gateway or a multi-protocol router must be used to facilitate the communication between iSCSI host and FC storage. The gateway converts IP packets to FC frames and vice versa. The bridge device contains both FC and Ethernet ports to facilitate the communication between FC and IP environment. In a bridged iSCSI implementation, the iSCSI initiator is configured with the gateway's IP address as its target destination. On the other side, the gateway is configured as an FC initiator to the storage array. Combining FC and native iSCSI connectivity. The most common topology is a combination of FC and native iSCSI. Typically, a storage array comes with both FC and iSCSI port that enable iSCSI and FC connectivity in the same environment as shown in the figure. iSCSI advantages. There are many advantages in iSCSI. These include cost-effective. iSCSI utilizes the existing Ethernet infrastructure, making it more cost-effective compared to the fiber channel SAN. Scalability. It can scale to accommodate large storage environment, making it suitable for both small and large-scale deployment. Flexibility. iSCSI can run over various network topologies, including LAN, WAN, and even the Internet, providing flexibility in the deployment option. Compatibility. iSCSI is compatible with existing storage system and protocol, allowing the organization to leverage their current investment. Ease of management. It simplifies storage management tasks such as provisioning, monitoring, and troubleshooting through centralized management interface. Data protection. iSCSI supports data encryption and authentication mechanism, ensuring data security during transmission over the network. High performance. With advancement in Ethernet technology such as 10 GBE and beyond, iSCSI can deliver high performance storage access comparable to fiber channel. In disaster recovery, iSCSI facilitates remote replication and disaster recovery solution, enabling efficient data backup and recovery process. Virtualization support. iSCSI is well suited for virtualized environment, providing storage resource to virtual machine efficiently. Unified storage. It allows the consolidation of storage resource, enabling organization to use the same infrastructure for both block level and file level storage. iSCSI use cases. There are many iSCSI use cases, and these include some small to medium business. Small to medium business with limited budgets can benefit from iSCSI for its cost effectiveness and simplicity in managing storage infrastructure. Remote office, branch office. iSCSI enables centralized storage management across geographically dispersed locations, reducing administrative overhead. Virtualized environment. iSCSI is widely used in virtualized environment such as VMware and Hyper-V for providing storage to virtual machine. Backup and disaster recovery. Organization leverage iSCSI for remote replication and backup solution, ensuring data availability and integrity. Media and entertainment. iSCSI is utilized in media and entertainment industries for storing and accessing large media files efficiently. Database storage. It is suitable for hosting database, providing fast and reliable storage access to critical data. Surveillance system. iSCSI can be used in video surveillance system for storing and accessing surveillance footage. Healthcare IT. Healthcare organizations utilize iSCSI for storing and managing electronic health records and medical imaging data. High performance computing. iSCSI can be employed in HPC environment for accessing shared storage resource among compute nodes. Cloud storage. iSCSI is integrated into many cloud storage service, offering block-level storage access to cloud-based application and service. Thank you.